Imagine a spacecraft that has the ability to break the laws of physics and traverse the solar system in half of the time it currently takes. That is exactly the revolutionary concept of NASA's helical engine, a groundbreaking propulsion system that could reshape the way we explore the cosmos. Space travel has always captured our imagination, but the limitations of conventional propulsion systems have constrained our reach beyond our celestial neighborhood. However, NASA's recent development, the helical engine, is generating waves of excitement among scientists and space enthusiasts alike. This propulsion concept holds the potential to propel spacecraft at unprecedented speeds, enabling us to venture farther and faster into the unexplored depths of our vast universe. So, what is the helical engine? How does it work? Have we finally uncovered the secret to the space-time continuum? Most importantly, how can this modern innovation impact the future of space exploration? Let's take a moment to contemplate the following scenario. Alpha Centauri, our nearest stellar neighbor, lies at a distance of approximately 4.367 light-years from us. This means that even if we were to embark on a spacecraft traveling at the staggering speed of 100 times the speed of light, it would still take us 4.367 years to reach our destination, and the utilization of rockets for space travel poses a significant predicament due to the enormous amount of fuel required to propel them. Furthermore, rockets have their limitations, including the maximum velocity at which they can propel a spacecraft. So we are faced with the challenge of developing a propulsion system capable of generating substantial thrust without the need to carry an excessive amount of fuel. This is particularly crucial because in the vast expanse of space, refueling stops similar to gas stations are non-existent. However, a recent study has indicated a groundbreaking possibility. Time travel in both directions may not only be theoretically feasible, but also safe. The pressing question then is whether one would be willing to partake in such an endeavor. At its core, time travel revolves around the concept of velocity, space, and gravity. For instance, the passage of time experienced by an individual standing on Earth would differ from that of a person traveling near the speed of light or in the vicinity of a black hole. Mathematical principles and the laws of physics dictate that time operates in this manner, even if our current technological capabilities do not allow us to travel at such extraordinary speeds. In essence, we are all engaged in a journey through time. A key element in understanding time travel lies in comprehending time dilation, a concept derived from Albert Einstein's theory of special relativity. Time dilation explains how the rate of motion alters the relative measurements of mass, time, and space. Einstein was the first to recognize that time is not a constant entity, but slows down as one traverses space at higher velocities. Consequently, time itself becomes a malleable illusion that fluctuates depending on the observer's perspective. If it were possible to travel at the speed of light, time would appear to pass significantly slower for the traveler in comparison to someone who remains at rest. Even astronauts in space experience the effects of time dilation, aging slightly slower than their counterparts on Earth. To engage in time travel, it is imperative to understand the functioning of space-time. However, an innate human drive compels us to seek solutions to significant challenges. This brings us to the endeavors of David Burns, an engineer at NASA who has dedicated his spare time to exploring potential resolutions to these profound questions. David Burns has conceptualized an engine that he claims could theoretically achieve 99% of the speed of light without needing a traditional propellant. Burns has shared his concept, known as the helical engine, on the NASA Technical Report server. According to the proposal, the engine utilizes the phenomenon of mass variation at relativistic speeds, specifically those near the speed of light in a vacuum. However, it's important to note that the concept has not yet undergone expert review on the NASA Technical Report server. Understandably, this paper has generated significant buzz, reminiscent of the early days of groundbreaking scientific discoveries. Some headlines have even claimed that the engine has the potential to violate the laws of physics. This engine supposedly has the ability to power a spacecraft without the need for fuel and produces no exhaust. All you have to do is plug it in, start the engine, and off you go. The helical engine is also known as the EM drive, or the impossible engine, due to its claim of achieving the seemingly impossible. In addition to Burns' engine, NASA has been exploring the idea of a warp drive, a theoretical propulsion system that could potentially allow spacecraft to exceed the speed of light. The concept of a warp drive gained popularity through the TV show Star Trek, but scientists have been seriously investigating it for decades. The underlying principle behind a warp drive involves creating a bubble or warp in space-time around the spacecraft, enabling it to traverse space faster than the speed of light without violating the laws of physics. This would involve manipulating the fabric of space-time itself, rather than relying on conventional propulsion methods. However, the main challenge lies in the immense amount of energy needed to create a warp bubble, and the means of powering such a system remains uncertain. Nonetheless, there have been promising advancements in recent years. At first glance, the EM drive appears somewhat similar to a rocket engine. However, it lacks openings and operates by bouncing microwaves within a closed chamber. This bouncing of microwaves is intended to generate a propulsive force. This is significant because all forms of rocketry rely on the conservation of momentum. To set a spacecraft in motion, some form of push is necessary. For example, when you jump, your feet push off the ground, an airplane pushes off the air, and rockets employ exhaust gas to propel themselves forward. However, the EM drive does not require any external push. It essentially consists of a container with microwaves bouncing around inside. Although this concept is fascinating, it is important to note that it will not revolutionize physics in the near future. As a thought experiment to illustrate the idea, David Burns describes a box with a weight attached to a line, with springs at each end causing the weight to oscillate. In a vacuum, such as space, this would cause the entire box to vibrate while the weight remains stationary. Think of a stabilized GIF. Overall, the box would continue to vibrate in the same spot. However, if the weight's mass were to increase in one direction only, it would generate greater thrust in that direction. If we were to base the concept on the principle of the conservation of momentum, which states that speed remains constant in the absence of external forces, this should not be possible. However, special relativity provides a loophole, which suggests that objects gain mass as they approach the speed of light. By replacing the weight with ions and the box with a loop, it is theoretically possible to have the ions move faster at one end of the loop and slower at the other. Burns' engine, however, is not a single closed loop. It is helical, meaning it resembles a stretched-out spring, hence the name helical engine. In this abstract, Burns explains that the engine accelerates ions trapped in a loop to attain moderate relativistic speeds, and then manipulates the velocity to induce slight changes in their mass by oscillating the ions back and forth along the direction of travel. The engine generates thrust. Remarkably, the engine operates without any moving parts other than the ions themselves, which travel within a vacuum line and are confined by electric and magnetic fields. This concept sounds impressive in theory, but it is not without its practical challenges. The details provided by the magazine New Scientist shed further light on the practical challenges associated with the helical engine concept. According to their report, the engine would require a helical chamber with actual dimensions, measuring approximately 200 meters long and 12 meters in diameter. This indicates that the machine would need considerable physical space to accommodate its operation. Furthermore, the energy requirements of the helical engine are staggering. To generate a mere 1 Newton of thrust, the engine would need an astounding 165 megawatts of power. This energy demand is comparable to what a power station would produce to accelerate a kilogram of mass per second squared. Such a high energy requirement implies that the engine's efficiency is significantly low, making it highly inefficient in terms of energy consumption. While the idea of achieving near light-speed travel without propellant is intriguing, the current limitations in efficiency and energy consumption need to be addressed for the engine to become a viable and realistic propulsion system. However, in the vacuum of space, where external forces are minimal, it might still have the potential to function. Burns himself acknowledged the efficiency problem in his presentation and the fact that his work has yet to undergo expert review, leaving room for potential errors in his calculations. While we don't possess a fully functional space travel engine blueprint, what we do have is a foundation upon which further development can be built. It represents our dream of venturing beyond our own planet and into the stars. While it may take many years or even decades before we can realistically travel to other planets or stars, contemplating the future's possibilities is undeniably exhilarating. Who knows what astounding discoveries await us once we can finally explore the cosmos? Only time will reveal the true extent of our potential. What do you think about this innovative engine? Share your thoughts in the comments section. And if you enjoyed this video, don't forget to hit the like button and subscribe to our channel.